We're going to go ahead and get started here. Um, my name is Brandon Brown. I'm an additive manufacturing application engineer here at Quest Integration, and thanks for coming to our supply chain coffee breaks. Okay, and a little bit about me before we go ahead and get going here. I have a bachelor's of science in mechanical engineering from Montana State University. I graduated back in 2017. I have over 20 certifications from Formlabs, Markforged, and SolidWorks. I've been a Quest employee for over 4 years, actually almost 5 now. And outside of work, I'm an avid mountain biker and skier. So in this webinar series, we're going to be talking about a few supply chain related benefits of additive manufacturing when it's implemented in your organization, namely the logistical workflow and end product benefits pertaining to the supply chain. In this specific webinar, we're going to be talking about the logistical benefits of additive manufacturing. I just wanted to mention too, is as I go through this presentation, if you guys have any questions, go ahead and use the questions box in the GoToWebinar interface to ask them whenever you have them, and I will answer them at the end. Okay, so in this presentation, we're going to talk a little bit about some of the process, maintenance, facilities, and inventory logistics benefits of implementing an additive process. So when it comes to process logistics and the benefits related to additive processes, additive has several advantages in this area. While it won't replace everything in all processes, where it makes sense, particularly more in the lower volume, higher complexity areas of production, like parts that are either lower volume or more complicated, or parts that are just really, there are advantages to implementing additive that we've talked about before. It's really, really great. So let's go ahead and contrast a couple traditional processes like CNC machining with an additive process. This is assuming the part is already designed though, and we're going to ignore post-processing because those can be considered equal for additive and traditional processes. So when looking at a traditional process like CNC machining, there are several steps you have to do before you even start machining the part. You have to get the design from the engineer or the designer and program the part, program the operations using a CAM software. This one, SolidWorks CAM in this case. Then you have to go find the stock that you need. You have to have the right material, the right size, the right shape, and if you don't have that, you have to order it and have it delivered. And then you have to typically cut that stock down to size if it's not already at size. Then you have to go and find or make the tools that you need, whether or not you have to go to your tool room or just locate the tools around your shop, or find the fixtures that you need if you're not using generic fixturing, or even make the fixtures in some cases. Then after all that's done, you have to set up the machines, go through the setup process, and then actually machine the parts. This might involve, not just one setup or one machine. This might involve a couple different machines, like say having to turn a part and then put it in a CNC mill to perform a couple operations. This could involve multiple setups. Additionally, these processes typically involve, like we mentioned, multiple tools, machines, people, and different materials. So there are a lot of areas that are prone to complication and delays because of this. Imagine somebody calls out sick, or you don't have a stock size you need, or a machine is down, or you don't have a tool, or somebody broke the fixture that you needed. A lot of areas for potential complications. Additive, on the other processes too, there are some processes like injection molding, or even other forming molding processes that are simpler at first glance, but they require you to make the tools required for this process, doing everything that we just mentioned. And this just compounds the issue. And then you have to actually deal with that process. So you have to go through and set up that process, obtain the tooling, obtain the materials, and then go ahead and run your parts in that process, which again compounds the initial issue. Additive processes, on the other hand, are much simpler. So the workflow is generally a lot smoother. you typically only have to load the file into your slicing software, which is similar to a CAM software, except it's much simpler to use, at least in most cases. Then you really have to just get the material that you need. There's only one feedstock type for each material. In this case, we're going to say it's a spool. Then you just have to set up your machine if it's not already set up. If you're properly maintaining your machine and using it frequently enough, a lot of times it'll already be set up. You might, worst case scenario, have to load the material that you need. And then you have to hit print and your part's pretty much done. This does make it a lot simpler to manage because there are less materials. There are fewer steps involved in the process. There's a lot less equipment involved for a wide variety of shapes. You don't have to say, like on a round part versus say a rectangular part, you don't have to use a mill versus a lathe. There's only one printer that prints both shapes. That's a kind of contrived example, but nonetheless, it is simpler for that reason. And there's also less people involved. The engineer that designed the parts or the designer that designed the parts in many cases is more than qualified to use a 3D printer, and that can be kind of integrated into their duties as well, kind of removing a third party there, a point of complication. Additionally, these machines are not committed to what they're set up for. They can, unlike these other machines where you set them up and they're set up to make one part in particular or do one job in particular, to swap parts on a 3D printer or to swap different jobs, all you have to do is change the job file, and potentially the material or a setup parameter or two, but it's much quicker to transition between jobs. Like if I'm printing that bracket out of Onyx and I want to print soft jaws out of Onyx, all I have to do is change the job file, and I can immediately, upon that part completion, I can just swap right over to producing something else with no additional setup. So let's talk a little bit about some of the maintenance and logistics benefits. The maintenance logistics benefits. Compared to say a large CNC machine or even like an injection molding machine, I'll just use a CNC machine as an example. These are very large, complicated, precise pieces of equipment. If you crash a CNC machine, you typically have to fly somebody out there, and that's not cheap, to get that working again. With 3D printers, they're very low maintenance, and even if you crash them, they're very easy to fix. They're very simple because they're largely software driven. There's only usually a few stepper motors in these guys, and an XYZ motion system, and maybe a few tubes like our X7 here. There's really no need for special equipment, tools, and training, minus maybe a nozzle wrench to resolve these issues. If it's really critical, like I know when we work with some of our customers, if it's really critical and they need to get it fixed right away, I can walk people through this over the phone, or over a video conference very easily. And you can watch a YouTube video and learn how to work on one of these machines. You just need essentially a set of Allen keys. This makes for very few failure points in these systems. So there's less parts to stock, less spare parts. There's less to plan for. You don't have to plan for as many contingencies, and it's much easier to resolve, as I was mentioning. These machines are much easier to work on than traditional manufacturing equipment. When it comes to facilities logistics and some of the benefits related to that, these machines have generally a pretty small footprint. They don't take up potentially precious space in your shop. You don't have to rearrange your shop or your workspace to implement a 3D printer, especially even a high quality 3D printer. They can be closer to their users. Many 3D printers don't need to be in the machine shop, period. Like this picture right here, I've done this before a couple times. He has a Mark II sitting right on his desk, so he can get, whether they're production parts or prototypes, he can kind of get these on demand and work with the machine in his own workspace without having to walk across, say, a campus to get to it. And then they have pretty minimal facilities requirements, so they don't take a lot or any really resources or site prep. Most, at least polymer and composite 3D printers, only really take a power outlet, or in some cases maybe a dedicated power outlet. This makes them really fast and easy to implement, and easy to move around if they need to be. You don't have to tear out a bunch of conduit and ventilation piping. And even if you do, a lot of 3D printers are pretty minimal on these requirements. I know, like our Metalex system, you have to put in some ventilation for the wash in the center and a special power line for the center, but again, those are pretty minimal compared to some equipment. So this is probably the big one, but additive manufacturing has a lot of benefits for inventory and the associated logistics. There's no need to store a large inventory of parts that you are printing now. So instead of having to, make a bunch of parts and anticipate demand and keep them in storage in inventory and ship them around, if you have a fleet of flexible printers, a fleet of flexible machines or 3D printers rather, you can simply print these parts when and where they are needed rather than storing them and shipping them around. This results in lower transport costs and it's faster. You don't have to say if you're out of the parts, go and do another production run of those or order them or wait for them to come. You can just simply print them on demand. And this really results in a much lower inventory, a much more flexible system. You only really need to keep a few things in stock. You only need to really keep some wear and replacement parts in stock and some print materials in stock. And again, you're not tying up a bunch of capital in parts that you may or may not use or may not go to waste. You're tying this up in, filament and consumables that can be used to make a whole variety of different parts that you're producing with 3D printing, which gives you a lot more flexibility. Additionally, it's probably a good idea to have a few buffer production parts if they're used very often, just in case demand suddenly spikes. But again, much lower inventory requirements and much more flexibility. Additionally, when you're working with a 3D printing provider, it's a good idea to make sure that these are in stock. The materials and where parts are in stock. Like I know we keep these in stock for our customers to make sure that they have access to them when they need them rather than having to wait to ship them all the way from Boston. So in terms of inventory benefits as well, I wanted to go over a quick case study. This is a company called BMF. They make metallic part finishing equipment. They have these, they basically spin these parts around in an abrasive environment in their machines. And they actually print these gears, these black gears that you see in the picture, and these pipe fittings on the left. So you might think, why are they doing this? These parts are probably, they're end-use parts. They're subject to some like notable like abrasion and stress requirements, especially in the case of the gears. Why would they print these? First of all, the gears are pretty hard to make and were expensive and time-consuming to make and obtain because they're unique parts. Instead of having to do that, they can now just print them and cut out all that complication. But this also gives them the ability for when these machines go down, these are critical production machines, so downtime is very expensive. They don't have to wait or ship parts. They can simply print them near their customers and send them, drastically simplifying the supply chain. In that case. Additionally, some high use customers are able to now print these parts on site with their own machines. Essentially eliminating wait time. It's just they wait for it to print and they're good to go. They pop the new part in and they're done. When it comes to the pipe fittings, these are actually used during installation. Typically, they had to stock these parts and figure out how to get them to their installers and how much they needed and what sizes they needed. It was just kind of a huge inventory problem. So what they decided to do was actually print these and have a digital inventory of these parts. So their installers can print these as late as a day before the install, the exact sizes and quantities that they need for their installs, drastically simplifying their supply chain and giving them a lot more flexibility. And this might seem a little bit outlandish, but especially a few years ago, this case study itself is relatively new, but newer technology in additive manufacturing and understanding of the processes that are out there and like where additive kind of fits into the production environment is really making this possible. And in many cases, what customers are finding is, well, at first glance, it might not seem practical to 3D print your parts. There are several advantages, especially in terms of logistics and organizational benefits that really outweigh some of the cycle time losses that you might see in 3D printing. So I hope you learned a lot from this webinar and talking about some of the logistical benefits of additive manufacturing and how it can help your organization in that way. Thanks for coming. We are having another session on June 18th about the workflow benefits of additive manufacturing. If you're interested in learning more and talking about this a little further, I would love to talk to you about this. If you're interested in learning about our 3D printers or what this can do for you, or just generally want to, talk about 3D printing in general, learn a little more about it and how it could fit into your organization, reach out to us at info@qintegration.com or call us at 800-370-3750. I'd be happy to have that discussion with you. We got a few upcoming events. We got a next week a webinar I'm actually going to be hosting on how to properly implement 3D printing in your organization on June 16th at 10 a.m. We have a 3D printing training coming up on June 17th. It's a full day, 1-day training. We have a two supply chain webinars actually, one on workflow benefits and one on end product benefits, like we talked about earlier in the webinar. Those two are happening on June 19th and June 23rd. And then additionally, I kind of wanted to plug our YouTube channel. So we have a lot of new videos up, a lot of new content. Some of those are really entertaining, especially the ones where we try and break some 3D printed parts. It's pretty amazing what goes on there. It's pretty entertaining to watch. I definitely recommend you check that out. So I'm going to open it up to questions now. And thank you guys very much for coming.